Welcome to MRS Bulletin's Materials News podcast, providing breakthrough news and interviews with researchers on hot topics in materials research. My name is Leay. Our ability to manipulate matter at the nanoscale has improved dramatically, but sometimes the development of analytical techniques and the associated data analysis lags behind. It's been possible to use electron microscopes to characterize materials in 3 dimensions for a while, but the data processing can take days and usually requires significant personnel effort. One long-running collaboration between data scientists and specialists is set to change all that. Robert Hovden from the University of Michigan explains.
The reality of how science works is there's a lot of serendipity and there's a lot of on-the-fly decisions that are being made during the time of the experiment. Jonathan set out to do tomography within a day, and he ended up doing it within 30 minutes.
Jonathan Schwartz is a PhD candidate at the University of Michigan. He spent 5 years developing software that allows for 3-dimensional nanostructures to be rendered as the data are being collected, building on a platform that has been around for even longer.
So we have this complete package that's easily downloadable, but we also had to integrate the capability to render live dynamic processes and be able to provide intermediate results as we're completing our experiment. So you could clearly see how, as you're progressing through your experiment, how your structure is changing. And then I also had to develop a lot of new and novel algorithms that's able to dynamically pull this data off the microscope.
The open source software, called Tomviz, is designed to work with any microscope and on any computer operating system. The new algorithms feed into a visualizer to build up a 3D image that evolves in real time, becoming more detailed as the experiment progresses.
And this isn't just surface rendering like a Shrek movie. This is full volume where every voxel in this 3D cube has to be assigned transparency and color values. So we had a platform, an open source platform that could do that, but it couldn't do it dynamically. So the software team at Kitware, such as Chris Harris and Marcus Hanwell, were really instrumental in getting that to work.
This collaborative effort has finally come together in the last 2 years when the software was validated and tested and has already been used on helical nanoparticles to determine their chirality, something that can only be known using 3D tomography. Led by Jonathan, these innovations lead to data processing that is orders of magnitudes faster than other solutions and means that adjustments can be made to instrument parameters to improve the final rendering of the 3D image in a single run. Tomviz can run on any modern computer, generating gigabytes of data that can render images with atomic resolution. It's freely available for anyone to use.
But
just love to see people use the tool, see all the kinds of tomography reconstructions that are produced out of it. Go download it at tomviz.org and give it a try.
This work was published in a recent issue of Nature Communications. My name is Leay from the Materials Research Society. For more news, log on to the MRS Bulletin website at mrsbulletin.org. Follow us on Twitter at MRS Bulletin. Don't miss the next episode of MRS Bulletin Materials News. Subscribe now. Thank you for listening.